All right, so we're gonna start off with this little bit of notes here. So I'm gonna call this the Pythagorean relationships or identities. So if you guys remember, the Pythagorean identity that we are familiar with is a squared plus b squared equals c squared, right? It's just the three sides of your triangle. So let me relate that to the unit circle for you. So I'm just gonna quickly, that's not very good, quickly draw a unit circle over here. And let's just stick with the first quadrant because it's basic. I'm gonna draw you a triangle. Okay, so here's a right triangle. And let's just call them A, B, and C. Okay, like the three sides of the triangle. It doesn't matter which one's A, which one's B. I'm just putting A on the vertical, B on the horizontal. C has to be the hypotenuse though. So this is us labeling a right triangle. And then, of course, this one would be your angle that we're talking about. Okay, so remember that the coordinates of this point on the circle are going to be the x value, so the horizontal length. Let me use a different color. It would be the horizontal length, so B. And then comma, let's pick a different color, maybe blue for the vertical length, the y value, which is A. And then if you remember way back when we did the unit circle, the x value, the b, is the same thing as our cosine. There's a lot of colors going on, but so cosine of the angle is our x value, remember that? And then we have the y value is the sine. This is kind of like, what, 2 chapters ago now? 1 chapter ago? Beginning of last chapter? I can't remember. But the x is the cosine and the y is the sine. Okay, and so for that black dot that's on our unit circle, it's cosine comma sine. And then we have, since this is a unit circle, our radius is 1, because on the unit circle, we have a radius of 1, because unit means 1. Okay, and so if we put this together into the a squared plus b squared equals c squared, well, if our a is sine, I don't know how to highlight this. If our a is sine over here, then I'll put sine squared theta, so that's our a. And then we have plus, then we have our b, which is over here, cosine. And then we have equals, and then according to our unit circle, c is 1. So I'm going to write equals 1 squared. Okay, so I just put sine squared plus cosine squared equals 1 squared. So that's one of them. Let me write it out in one color and I'll circle it. Sine squared theta plus cosine squared theta equals 1. 1 squared is just 1, so I simplified it there. This is one of your Pythagorean identities. Now, if you don't exactly remember how we get to this, that's totally fine. Just remember this for now. This is your most basic Pythagorean identity in trig. So write down the thing in the box, the thing with the star next to it. That's the thing you should be writing down in your notes, okay? So we have sine squared plus cosine squared equals 1. So this is the most basic form of the Pythagorean identities in trig. We're going to derive 2 other versions from it. So the first version is we're going to divide everything by sine squared. Okay, so we divide everything by sine squared. Just let me rewrite everything out first. And then, like I said, I'm going to divide everything by sine squared. Okay, and so when you divide everything by sine squared, you're going to get sine squared over sine squared is 1 plus cosine squared over sine squared is cotangent squared. And then 1 over sine squared is cosecant squared. So here is another Pythagorean identity. It's literally just the first one divided by sine squared. Okay, so this is one of them, another one of them. I'm going to put a dividing line over here. We're going to get the third Pythagorean identity, and for this one, we're going to divide, not by sine squared, but by cosine squared. Okay, so I'm going to rewrite everything out. Sine squared theta plus cosine squared theta equals 1. That's our original. Now, like I said, divide everything by cosine squared. Divide by cosine squared. Divide by cosine squared. And then we get sine squared over cosine squared, that's tangent squared, plus cosine squared divided by cosine squared, that's 1, equals 1 over cosine squared is secant squared. And so, if you have been zoning out, the most important things you write are the 3 things in the boxes, and I guess the title. So please write those 3 things down at least, and I'll give you guys a little bit of time while I pause the recording so you get more time. All right, so let's save that to photos, and then we zoom back out onto delta math. Let's start with the Pythagorean trig identities right over here. So it says, simplifies to a single trig function with no denominator. So let me screenshot that. And then I'm actually going to rewrite the 3 boxed things out so that we can refer to them. So I can point, I guess, because otherwise I have nothing to point to. Oh, I guess I wrote that like reversed. Let me rewrite that. So our textbook has it in the other way, so there we go. And then okay, so here are the 3 things that we have in boxes. And so when you're looking at this problem over here, it says secant squared minus tangent squared. You ask yourselves, which of these 3 things has a secant and a tangent? This one. This one has a secant and a tangent, right? The other one, the first one has sine and cosine. The last one has cotangent and cosecant. So we look for the one with the secants and the tangents. So I found that. And then so I'm going to use this one. I'm going to write it again. So I just need to rearrange my Pythagorean identity, this thing. I need to rearrange that so that it becomes this entire thing. So secant squared minus tangent squared. How do I get that to happen? Well, I have tangent squared plus 1 equals secant squared. So if I subtract tangent squared on both sides, I get 1 is equal to secant squared minus tangent squared. And so now, this thing matches the problem they gave us. So therefore, our answer is 1. Any questions? Okay, you can always interrupt me if you have a question. But in this case, our answer is 1. So I'm going to go enter that in now, since I don't see anybody saying anything. 1. All right, so let's go to the next problem. So this one has cosecant squared minus 1. Let me write out the 3 again. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And then 1 plus cotangent squared theta equals cosecant squared theta. Sorry, that one was messier. I just wanted to write it fast. Okay, so then you look at the problem we are given, and it says cosecant x minus 1. And you're like, okay, which one has cosecant? This one has cosecant. So this is the one we're going to be using. So let me rewrite it out. Okay, so this is the one we have. And then we need to ask ourselves, how do we get this thingy? That is the ugliest star I've ever drawn. How do we get this thing to look like that thing? So we want a cosecant squared minus 1. How can we do that? Well, we have a 1 on this side. So I'm going to subtract it, so it's over with the cosecant squared. So then we would get cotangent squared theta equals cosecant squared theta minus 1. Now we have forced it to look like this. They are the same now. So our answer will be cotangent squared theta. Okay, any questions on this one? Alrighty, if you do have a question, please interrupt me. Other than that, I'm entering this in now because you haven't said anything. So we have cotangent squared. Oh, I guess it's not a theta, sorry, it's an x. But the same basic idea. Cotangent squared x. My bad, I thought it was a theta. Same thing. Any questions? Okay, so the answer. Let's do one more together. We have 1 minus sine squared theta. Instead of rewriting the 3 out, I'm just going to say the only one of the 3 that has a sine squared theta is this one. So sine squared, not a theta, Miss Jade, it's an x. Okay, sine squared x plus cosine squared x equals 1. Okay, and then you're like, how do I make this thing turn into that thing? Well, I need to have 1 minus sine squared, so I'm going to subtract sine squared on both sides. Then I will get cosine squared x is equal to 1 minus sine squared x. And finally, that means we have made this piece look just like this piece. And so therefore, our answer is cosine squared x. Any questions? Okay. So cos squared x. All right, so that would be it for this section.